Betelgeuse, situated in the Orion constellation, is one of the most recognizable stars in the sky. Its vibrant crimson color and prominent position have made it a favorite among stargazers and astronomers alike. However, what truly captivates astronomers about Betelgeuse is its enigmatic behavior. Known as a variable star, it pulsates, expanding and contracting in size over time. This pulsation causes fluctuations in its brightness, sometimes making it one of the brightest stars in the sky, while at other times significantly dimming. Betelgeuse is an immense giant, with a diameter over 1,000 times that of our Sun. If placed at the center of our solar system, it would engulf the inner planets, including Earth, and extend all the way to Jupiter. Its colossal size and mass classify it as a red supergiant star nearing the end of its lifespan. Yes, this behemoth star is dying, but that alone is not what piques our curiosity, as stars meet their demise frequently. What has astronomers on edge is the recent dimming of Betelgeuse. In late 2019 and early 2020, the star underwent an unprecedented dimming event, losing a significant portion of its brightness. This event sparked speculation and curiosity among scientists worldwide. Several theories emerged to explain Betelgeuse's dimming, but one possibility stood out and was later confirmed by the Hubble Space Telescope. According to Hubble's data, scientists discovered that the star had ejected a massive cloud of dust, partially obscuring its light from our perspective. However, since the dimming event in February 2020, Betelgeuse has not exhibited similar behavior. What we do know is that as the star recovered from expelling a significant amount of its inner materials in late 2019, an event known as the Great Dimming, its surface began oscillating like gelatin on a plate, and it lost its natural 400-day pulsation, which had been observed for at least 2 centuries. Yes, Betelgeuse continues to display peculiar behavior, and looking ahead, it will eventually reach the end of its life and explode in a brilliant supernova. However, the exact timing of this event remains uncertain, except to a team of scientists. According to them, the explosion may be happening right now as you watch this or could occur in the near future. Welcome to Nebula Mind. If astronomers were to guess which nearby star in the Milky Way is likely to go supernova next, their bets might be on Betelgeuse. This bright red supergiant star, marking Orion's shoulder, is nearing the end of its life and is located less than 1,000 light-years away from Earth. But how close is it to going supernova? And will we be around to witness it? Typically, astronomers suggest that it may explode within the next 100,000 years, which is soon on a cosmic timescale but not within a human lifespan. That, in a way, is disappointing. However, our calculations might have been off, and the spectacle could unfold before our naked eyes at any time. A new study by Hideyuki Seo and colleagues from Tohoku University in Japan suggests that the star might be further along in its evolution and closer to exploding than previously thought. How do they arrive at this conclusion? It's through studying the star's pulsations. Betelgeuse is known for its instability, regularly expanding and contracting with overlapping overtones. By observing its brightness over the past century, astronomers have noted changes occurring over periods of 2,200 days, 420 days, 230 days, and 185 days. Typically, the 420-day cycle is considered the primary pulsation, with the shorter cycles acting as overtones. The 2,200-day, or 6-year, period is not usually associated with these pulsations and is instead referred to as a long secondary period, a phenomenon of unknown origin common among 1/3 of supergiant stars. If the 420-day period is the primary one, Betelgeuse would span the equivalent of 800 to 900 suns lined up in a row. Placed in our solar system, it would almost reach the orbit of Jupiter. However, Seo and colleagues believe this could be an underestimate. If the 2,200-day cycle is the primary one, with all the other cycles considered overtones, the star would be even more massive, spanning the equivalent of 1,200 suns, wider than the orbit of Jupiter. Correspondingly, the star would be further along in its life cycle. Stars like Betelgeuse burn brightly and rapidly. Like the Sun, they begin by fusing hydrogen into helium within their cores, but they quickly transition to helium fusion, forming carbon. Carbon then undergoes fusion to produce heavier elements. Around the core, lighter elements burn in shells, causing the star to expand outward like a hot plasma balloon. Seo and colleagues employ computer simulations to observe the evolution of stars from birth to old age, predicting the pulsations they should observe at each stage. They find that all four pulsations, ranging from the 2,200-day cycle to the 185-day cycle, can be explained by a breathing star in the late stages of carbon burning. After carbon is depleted in the core, a core collapse leading to a supernova explosion is expected within a few tens of years, write the researchers. However, determining precisely when the carbon will be exhausted is challenging because the pulsation periods do not change significantly at this late stage. It's not possible to estimate exactly how much carbon is left in the core at present, says Seo. We can only guess that the time to carbon exhaustion is probably less than a few hundred years. So, to put some headlines into perspective, Seo's group is not claiming that Betelgeuse will explode tomorrow or even in the next decade. Their assertion is that Betelgeuse could go supernova within 1,000 years, rather than 10,000 or 100,000 years. The 2,200-day pulsation, if it is a radial one, also presents other challenges. Spectroscopic measurements reveal that the star's surface expands and contracts at a rate of approximately 1.5 kilometers per second, 3,300 miles per hour. If the star is breathing at this rate over a span of 2,200 days, its diameter would change by 180 times the size of the Sun during each cycle. Even for astronomers, that's a considerable variation. Furthermore, the 2,200-day pulsation would also impact the pulsation of the overtones. For instance, the 400-day cycle would not always be precisely 400 days. When the star expands to its maximum size, this overtone would lengthen. Conversely, when the star contracts, it would shorten. These changes would be expected to repeat systematically every 2,200-day cycle, notes McLeod, and I don't think we see evidence of that in Betelgeuse's long-term light curve, which exhibits more random variations around the typical 400-day cycle. Now, for those who are unaware, when a star exhausts its hydrogen fuel, helium begins to fuse into carbon, leading to swelling in the star. As all fuel is consumed, and the remaining elements cannot sustain fusion against their own gravitational forces, the core collapses to form a dense neutron star, and the inrush of surrounding gas rebounds, resulting in a supernova explosion. Betelgeuse is a red supergiant star with an estimated age of at least 8 million years. It is believed to be in the final stages of its life cycle, having consumed all the hydrogen in its core. So, will we be able to witness the Betelgeuse explosion? If we could live for another couple of thousand years, then perhaps. What a spectacle it would be to behold, right? Let us know in the comments below, and don't forget to subscribe to Nebula Mind.